Saxon's Calculus Lesson 16. So due to a technical difficulty while recording the lesson the first time, I'm now needing to redo it. So all of the answers are already written here, but it's far better than you not being able to see any part of what I was doing. So continuity, as I have worded here, is talking about a continuation of the graph, the curve, the line. There's no gap or asymptote there. Then it is continuous, or it has continuity. If it has a gap or it has an asymptote in the graph, then it falls under discontinuity. It is not continually flowing without a problem. So in this particular picture, I see that I have a hole here and a hole here and an asymptote here, which skews this line. I can't cross the asymptote line. So this is definitely a picture that shows discontinuity because it is not continuous. That was an example for something else. And then it moves to the definitely calculus term limit, and a limit means that we are getting close to something. So on the top of page 92, they show you a series of pictures, graphs like these, where it shows an asymptote and it's curving you up, and in their picture it's on both sides. Or in another picture, they show two curves with two different asymptotes where the X line is acting as an asymptote. Then they show a circle with a dot, so there's the gap. And then they show, and that's where I was doing this one, a curve with a gap in it. That's why that line was marked off with the pen there. It's supposed to be an open hole. That's going to be discontinuous, discontinuity there. And then their last example shows a line with a hole, but then there's a dot up above it, not with any other lines, just the dot up above it. But all of those are showing that they are discontinuous. And then it talks about a vertical asymptote. And so that's vertical running this way. And it means it's crossing the x-axis. And if you have one of those, then you also have the discontinuity. I think we've covered that fairly well. Then in part B, they move on to left hand and right hand limits. And there was I'm trying to cover what I had here. So if you see, I'll go ahead and do this one. If you see the word limit, and then underneath it, it has something as example, x yielding to a 5 from, and then there's a negative sign or a positive sign. This is the book's way of asking for limit. Now, the positive and the negative I discussed and we'll have to repeat here with this graph in just a moment. But the negative indicates the direction I'm coming from. I'm coming out of the negatives and arriving at the 5. Or if it had a plus sign, I'm coming out of the positives and arriving at the 5, and I want to list and say what it's saying. However, in example 1, which was the one here, they didn't use this format. They did f of x, or actually they did say limit of f of x with an arrow here rather than underneath it. It was just, this isn't the simplified form of asking it, this is, but for some reason they started the first example this way. Limit of f of x, referring to this particular graph when you're getting to the 3, and this is part A, from the positives. So from the positives, arriving at the 3, I am not coming down this line. I am actually coming this line, and so I'm heading to the 3. Okay, so I'm heading, so because if I had used this line, I'm not allowed to touch the 3, so I need to be using, well, actually, no, that's fine. I am coming here, but I can't touch it. So, but what number would it be at? If I could touch it, it would be at 2. 2 is the limit. In part B, it gives you the arrow and it says 1 from the negative. So I'm approaching from this side. So I'm using this line and dropping down to the 1. So I'm arriving at, but not actually allowed to touch, 1, and that was the answer to B. C did 3 from the negatives. And so from the negative side, it's not this line, it's this line. So I'm sliding down to here. What is that number? It's 1. 1 was the answer to C. And then D asks for the limit to 1 coming from the positive. So it's not this line, it's this line sliding, and that would get me to the 2 when I'm there. So that was A, B, C, and then D's answer. Okay, did I skip anything else? Not of major significance. Okay, so then let me actually make sure you're seeing, that's where we got in trouble before. Okay, that's better. Example 2 was this one, and it says, find the limit of x approaching the 3, and originally that was from the positive side. So from the positives coming to the 3, I'm climbing up this line, and I'm getting to approximately 40, and so approximately 40 was my answer. And my reasoning there was the fact that on this graph, I can't tell, I mean, it might be 39.9 or 0.99. So I can't know for sure, but we're going to use the approximate squiggly equals for 40. Now what happens when I approach it? Part B was from the negative. So I'd crossed off the positive and wrote a negative. So now coming from the negative side to the 3, I'm falling down the line, but I'm still getting at the same point, approximately 40. So it was the same answer for both. All right, then in this example 3, it says, given that, and they gave me this f of x, this function statement, I needed to graph it, so sketch the graph of f of x, and then find, there's a part A and a part B question. So the first thing we had to do was draw this picture. And so what I did was I said y equals 1, so I'm crossing the y-axis at 1. But where am I? I'm bounded by this information. Where is that happening? When x is greater than or equal to 0. So since it was or equal to, I colored in the dot. And then everything greater than are my positives. So this line continues from the positives. This one tells me to cross at -1, so I go down to here. But this tells me that I can only graph the numbers where x is less than 0, so where I have the negatives. Since it doesn't have the or equal to, it's an open circle. And remember, if I had put a colored dot here, I would have failed the vertical line test because I would have passed a dot and a colored in dot, and then it wouldn't have been a function. But this is okay, I have a dot here and a gap here. So gap, and then through the negatives, we're heading with this straight line. So now that we've got our graph, the question said for A, the limit of coming to the 0, and originally A was from the positives. So from the positives coming to the 0, I am landing at 1. Then they changed it in B to the negative format, and so coming from the negatives up to the 0, where do I get to? Well, that's almost touching, but not quite, the -1, so that's the limit there. And that is the repeat of lesson 16.